Quick show of hands, how many of you have ever booked a cab or a taxi using your phone? Everyone, right? We've been using Uber or Lyft or some of these ride-hailing companies since a long time. But how many of you have booked an autonomous ride where there's no human in the car? It's completely driverless and it comes to pick you up through your phone. Wow, 3 people. Amazing. At Cruise, we are actively working to realize the dream of self-driving cars so that we can transform the experience of ride-hail and delivery as we know of it, such that each one of you in this room and beyond can experience the magic of driverless cars. Good morning to everyone. I'm Utsav Shah. I work as a senior data scientist in the AI team at Cruise, and I'm super excited to talk about how we are building a ride-hail business with self-driving cars. Today, I'll speak a bit about Cruise, what it does, the core technology that powers the software behind self-driving cars, our ride-hail product and how it's different from some of the other ride-hail businesses, what data science does at Cruise and how it empowers the entire ride-hail business, and lastly, a sneak peek into the future where we reveal some of our scaling and expansion plans for the company. So at Cruise, our mission is to improve the lives of people in our cities by safely connecting people with things, experiences, and places that matter the most to them. This is a quick history of Cruise. It's been a decade since we launched, so we started in 2013. However, it feels like this is the best moment to work at Cruise or be at Cruise because this is the first time that our driverless product or driverless cars are cruising around major cities across the US, and tons and tons, thousands of riders are taking autonomous rides every day in those cities. So let me give you a bit more context, and this is probably a more interesting part to some of you, is what's our core technology that powers the self-driving industry or the self-driving technology. So first, the car sees, just as all humans do. The first thing that we do is see. However, the AV sees much farther than a normal human can, hundreds of feet ahead through our different sensors. We try and cover each and every angle within our AV such that it builds a 360-degree view all around the AV, and it gives us important information such as where's the pedestrian at, where are the bikes at, where's the double parked vehicle, where's the trucks, the construction zones, the weather, the road conditions, and all of those things. All of this information is taken into account and is fed forward to our next system, which is think. So as humans do again, we see, we percept, and then we think upon what we want to do. Similarly, the AV also thinks. We do thousands of computations every second such that we can choose the best path forward to complete the goal or the objective that the AV has to do. Post this, again, it feeds forward all of this information and tells the limbs of the vehicle, which are your throttling, your braking, and the steering angle, on what to act, on how to drive through the roads of San Francisco or whichever city that we are present in. Right? So remember that, see, think, act. Now, everything that we do at Cruise has a very safety-first principles, right? So over the last 2 years, we have driven over 1 million autonomous drives or driverless miles with no human in it, and it has resulted in 54% fewer collision rate when compared to human benchmark driving. In all of our decisions at Cruise, we ensure that we have a safety-first mindset. All right, since now you have a bit of flavor about how the AV industry works or the autonomous cars work, let's dive deep about our product and how our ride-hail product is actually different from some of the other ride-hail businesses. 2 distinguished factors. One, our entire fleet is all electric. It's all electric. The second, and which is more important, which is what I'm here to talk about, is that every car of ours is self-driving car. So it's completely driverless, there's no human in it. If you're imagining how you can actually take a ride, a driverless ride, you can just join the wait list. If you happen to be in one of the cities that Cruise is present, You can just sign up on the wait list, download the app, and then the experience is very similar to how you would take a Uber or a Lyft. So you just request the ride, pick your destination wherever you want to go, and hopefully a driverless car, if matched, will come to pick you up. This is a surreal experience where there's no human. Some of you might have experienced this through your journeys, but for me, taking my first ride was a surreal experience. It was magical. So I urge you to take one of these rides if you're present there. But a driverless car will come and pick you up at your pickup destination. You might have to walk a bit depending on where you pick up and drop off. But that's about it. You unlock your doors through your phone without any human interaction. You get in the car, and hopefully there would be a start of a magical experience for you. All right, so what do we do as data scientists and analytics professionals at Cruise, and how do we empower our systems such that we operate the ride-hail business, right? Now, first, I want to give you a bit of a flavor of the magnanimity or the humongous amount of data that's generated. So while running our cruise ride marketplace, we have the demand side data, so all data from the consumers get accessed. The supply side of data, so from our vehicles, the entire marketplace, our routing, mapping, etc. And then the entire in-app flow. So whenever you click something in the app, all the in-app analytics, the payments data, the pickup drop-off data, the routing, mapping, all of this data. So we have tons and tons of data which is generated by the AV, our marketplace, the consumers, all of these different multiple systems. As data scientists, we ingest and transform this raw and messy, complex data into something meaningful such that it can power our real-time systems and some of our downstream analytics services as well. The real-time systems, we'll talk more about this, because these are demand forecasting models or customer segmentation, some of our downstream analytics and whatnot. Now, data science sits at the center where it powers the core ride-hailing experience. And these are some of the specific examples of how we run this and how we build our models, right? And we do all of this to improve our ride-hail service. I'll give you a sneak peek about each of these in brief because we don't have a lot of time to get through details. But the first thing and one of the core objectives of being a data scientist at a ride-hailing company is to build an efficient marketplace. Now, what does an efficient marketplace means? Every hour that the AV is on the road, which is available for ride hail or delivery, we want to ensure that it's getting utilized the maximum amount of time. If you consider your personal vehicles, it's probably used 5% of the time. It's mostly sitting in your garages or parking, etc. But when you're running a ride-hail company, you have to ensure that you are maximizing the amount of utility that you can get from every AV. What this does is that this turns this into an optimization function for us, right? Where we have to ensure that the vehicles are utilized in a maximum amount. We do this by taking into account demand forecasting models, which maps the geospatial demands across different neighborhoods across San Francisco or whichever city that we are mapping. This is a nice map of San Francisco. You can see the downtown is marked in red, the north in yellow, and you don't have much traffic on the western side or the coast side if you're in San Francisco. We take this into account, and our ride-hailing operations are a bit different because we don't have humans who are driving. We can actually control the entire fleet and tell the AV where to pre-position itself such that we can cater to the demand at that hour in that neighborhood. So this is a bit different than how Uber, Lyft, or some of the other ride-hailing companies would operate, where we are controlling most of our or all of our fleet. So hence we built a pre-positioning algorithm to place our AV strategically so as to optimize the amount of efficiency or utilization that we can get from every AV. Now, the challenge of owning an entire fleet is that we have to then manage the entire fleet as well. Now, what do I mean by managing? So our cars are, again, all electric, all self-driving or driverless cars. The challenge that comes with that is that we have to take into account the vehicle's location because there's no human telling us the location, the charging status of each of the AV, the weather conditions, the demand forecasting, all of these things. And we take into account all of this to ensure that we are having a maximum amount of service uptime. Now, service uptime, if you don't know the term, don't worry. is how many cars are there in the garage and how many of them we can actually deploy on the roads. We ideally want to deploy 100% of the cars all the time, but that's not feasible because electric vehicles again take some time in maintenance, in some time in charging, etc. So we're building all of these algorithms such that in the entire fleet, when we have thousands of vehicles, how do you optimize or increase the service uptime such that we can deploy the maximum amount of AVs or autonomous vehicles on the road so that all of you can experience the magic of self-driving cars? But not just on the road. There is a lot of operational autonomy that we have to have within our facilities or within our garages as well. Now we need to do this because again, we want to minimize the amount of human interaction. And once you scale and expand, you can't have all of your drivers just working in your garages, parking the cars or going for charging for each of these cars. So we have intelligent algorithms that are designed to handle routing, mapping, charging, parking, etc. within our garages and facilities as well. There's a cool GIF about a AV just getting out of the parking itself and going into dispatch. So we have to develop all of these algorithms to teach the AV all of these things. Now, enough evidence about how we control the supply side of things. We are a consumer-driven business. We are interacting with consumers. So how do we actually solve for the consumers? This is a nice segue into focusing more on the consumer side of things. What we do is we are trying to constantly understand the pain points that the customer faces by booking a ride, or they have a lot of preconceived notions about self-driving cars. So how do we make sure that we provide the best experience for the consumers? We analyze a lot of data that we get from in-app analytics, understand our conversion funnels, user journeys, and understand the common pitfalls through our app process or through the booking process so that we can provide the best experience, customer experience possible. Everything that we do at Cruise, or a lot of data scientists come up with interesting ideas and then validate it through different hypothesis testing. So if you have ever done in a product company or any of the technology companies, you would know this, that every decision that's taken at most of the product companies now are through experimentation. At Cruise, we do the same. We run tons and tons of experiments. However, there's a bit different flavor of experimentation where we are able to test not just on the consumer side, but also on the AV side, where we can split different AVs into different groups or ABC sections and turn those into AB experiments or randomized controlled trials on our AVs as well. So things such as marketplace optimization or fleet management, all of this, if there's a new version of the algorithm that we want to test, there's this added flavor of experimentation on top of the general experimentation that every product company does, right? Finally, we care, as I said, mostly about customer experience and what's the customer's journey throughout the booking process. How is this different from analyzing such as Uber, Lyft, or whatnot? We have the power to analyze the car or the AV experience as well. So we know how many times the AV made a brake or a hard brake, how many times did the AV swerve, and how many interactions did the AV have with other pedestrians, other cars, etc. We take all of this data into account at each trip for each customer and then provide actionable insights to our engineering teams or machine learning teams so that they can solve those individual problems so as to provide a delightful experience for every trip and every customer possible. Now let's sneak peek a bit into the future. So how do we scale from here? We have some of our AVs in the hundreds in San Francisco right now. We are present in Austin and Phoenix as well. So that's our current footprint. Our offices are headquartered in San Francisco. And then we have international partnerships as well in Dubai and Japan with Honda and some of the other OEMs as well. This is something which is really cool that I want to share with you about, is the Cruise Origin purpose-built vehicle. So you see this car is like a box, and this is going to be a, again, all-electric, self-driving car, but this is purpose-built for ride-sharing. And this is going to transform the way that we think about transportation. If you think about the cars, it has 4 wheels, the same steering wheel, a brake pedal, engine, all of this is a normal that we have seen in cars while growing up. And probably our fathers have seen the same, and cars have not really changed in the last 70 or 80 odd years or so. But this is going to change the future of transportation. The average lifespan of a Cruise Origin is 6 times more than the average car. This looks really big from the inside. It has a lot of space because we have removed most things that you would find in an actual car. So it's actually the same size as a Honda Civic, so it's the same length, but it feels much more, and it has a lot more capacity within it because we've removed a lot of the things that you would see in a car. All right, we are in the early commercialization phase. So you'd see that we are at about 2023, where we've driven a couple of million miles. There are thousands of riders who are taking our rides across major cities in US. But this is, again, the most exciting part because we're at the cusp of doing something magical at scale. And that's really where the fun begins, right? So this is where rapid scaling and beyond would happen in the next decade. And I'm super excited about this part, and then being at Cruise, working in the self-driving industry, to be able to serve the users and the customers the magical experience that I felt and so many of the others have felt. With this, I urge you to take a self-driving car or a driverless ride. If possible, if you happen to be in San Francisco or Austin or Phoenix, please do try out Cruise. It was a magical experience for me. And I can vouch for the experience because my parents took a ride a month ago. And if the AV can make an Indian parent proud, it can do many things. So I urge you, those are my actual parents, not AI generated. So that's my dad. It's fun having you. Hopefully you learned a couple of things, a couple of new things. And I'll be around here, so catch me if you want to learn more about the AV industry or self-driving cars, or just learn more about the ride-hailing business or the industry. But yeah, hopefully you have tons of fun at the AI4 conference, and yeah, good luck.